Alright, what's going on? I'm solving this problem today. Find two non-overlapping subarrays, each with target sum. So for this problem, it's kind of like you need to find two non-overlapping cases. So at the beginning, it seems like you just do a while loop. You do a while loop through one section, and then you do another while loop through the second part, and find if there's another subarray, and you just keep doing it. You just iterate through, and then you iterate through the next one, and then this time complexity is like 2 to 4 loops, so it's probably O of n squared. That'd be if you brute force it. Now we can try that out, but let's go straight, because I know this is a dynamic programming problem, and to solve it with dynamic programming, all that I'd have to do is basically this. So the idea with dynamic programming is that you create a prefix sum array to keep track of the sums so far, and then you keep the prefix sum array use accumulate from Python itertools module, and then you take that, and then if you take any value from that accumulation and you subtract it from another value, so you create this index mapping, and the idea is that the index mapping will basically tell you that for each, if a previous value exists in your index map, then that means that this current target minus value is actually equal to 3, because it's kind of like taking subtraction between two prefix sum arrays. So if you subtract two prefix sum arrays, that's how you can get the sum in a range, right? That's kind of the idea here, is that with prefix sum array, if you take like regular, if you take like prefix sum, prefix array at, I don't know, whatever, I minus prefix array at j, you're kind of like computing the range from I to j, I guess this is like to be j to I, whatever, but anyways, you're computing a range, and that's the idea here. But the thing is that you want to save your previous values as you've seen, so whenever you take a subtraction, you see if that range exists. So the idea is that you store like this prefix array map, which I'll start out with 0 and -1, which I'll explain in a bit. This is really just for basically if you have an element at the beginning that's equal to the target. But basically this prefix array map is going to store every value from your prefix array and do that. So like for instance, you're going to do IV and enumerate, and then because I'm just kind of using this is going to do all the work for me. It's going to create the prefix array right here. So, and I have this prefix array map. So how could I possibly check if a value already exists in my prefix array map? So like, how could I check that if there's a range that is equal to the target? Well, what I could do is I could take the current value that I have, the v, and subtract it from the target, or do the target minus, it doesn't matter. And I get the value, right? I get the value v minus the target, right? And let's say that value is equal to 2. Now, if that 2 is in my prefix array map, that means there's another element index that adds up to 2. So that means if there's a range from that previous, wherever that previous to the index of it, to the current index I, there's a range that's equal to the target. That's what that means. and that's what you do. So you check if v minus a target is in the prefix array map, and there's certain stuff you want to do, but let's just talk about updating. So every time you do something, you need to update the prefix array map at your current v, and you set equal to the current index. Okay. Now, once you have something that's in your prefix array map, you want to kind of like start dealing with answering the question. So you want to find the minimum sum of lengths. So one way to find the minimum sum of lengths is to first off keep track of the lengths, and okay, so one way is to keep track of the length. So if you do don't need this. So if you do something like length equals so you're going to keep track of the best lengths I've seen so far, and then I'm going to have something called answer and best, have those equal to infinity. So basically, you're going to get the right, well, you're getting the left index. So you get the left index, and the left index is equal to prefix array map for the current value. Now, as long as it's greater than -1, well, that was lovely. So we always need to update our best, right? So we're going to update our best based off the min, between the best, and you want to take I minus L. Now the thing about why would I want to do -1 up here? Because let's say my first element is 3 and the target is 3, so we get 0. So the left is -1. So if the left is -1, and we do 0 minus -1 is equal to 1. So that's why, because the best should be 1. The best length we found so far is 1. And and if we're moving forward, like let's say to L might be 0, I might be 2, it'll still compute us the appropriate answer. I also need to update my length at each instance to be equal to the best that we have found so far. And then the thing we have to do is if when we take v minus target, if it's equal to 0, right? If it's equal to 0, that means that's our first subarray. Right, that's our first subarray. Look at this example. Target is 6, right? So you go 4, 3, 3, 2, and then a 6. So this 6 is where you're going to get like a response, and you're going to get like a length. And it's going to be like, it's not really going to work out. But like, so we have to check that L is greater than -1, because if it's equal to -1, we don't want to, well, let's not think about what we're going to do here. So we're going to update the answer, and the answer is going to be the min of the answer, and it's going to be I minus L plus the best value so far, right? Right up to this I would have been our best length. Then we're doing answer. So I believe that this works. Here. Let's read that. Okay. Okay, that should work out better. We're gonna see what we get as a result. Index out of range. I forgot to do that. Yeah, that should have been. Right. If, alright, we return answer if answer does not equal if else -1. So, output's infinity. This is kind of interesting. So, for some reason I think it's infinity. So let's think about what's going on here. So, lens of I is going to be infinite at the beginning, right? So, it's not really going to matter. But we update lens of I to be the best, and the best value should be equal to 1 right here, so this should be that makes sense. Let's actually print out right, so the lens, you should look at the previous one because you haven't updated for the current one. So that actually works. We'll check if it works for everything. Nope, it doesn't work for this example. Let's see why. Let's see, what is this? 1617. 161. Okay. So anyways, you get infinity. So you get 7. You get 7. Okay, this is what I was afraid of. It's it's not quite accurately identifying if there's an overlap. Then again, I guess 7 minus 0 would have meant that it would be 2 plus infinity. Okay, let's print our answer. Answer at each step. So we have infinity, and then we have 4. Sure. Okay, so we have infinity, and then we go to the next iteration, and we do, this one is going to be 8 minus 7, which is equal to 1, and 1, that's a pair prior, so it's like, let me use that. Alright, I figured it out. So, this would be length of L. It is rather fast too. But, the reason why, so, I gotta practice a problem like this. So this problem is kind of like using the concept of, so I kind of messed up in the details, but yeah, so it's using the concept of getting the range, whenever a range between two prefix arrays, basically, you know, how you normally compute a range when you have prefix and arrays, it's using that concept to solve the problem, because anytime that range is equal to the target, you know, you're good to go. That's why you say with this prefix array map of these previous values, and so on. But then there's another thing you have to do, which is you have to make sure that they're not overlapping, which is why when you look at the lengths, basically the length stored the best length so far, you have to look at it based off that index. So like up to whatever index this range takes me back to, you know, like what was that index that the range, right? We have a range that's equal to the target, and from the start of the range, the left side pointer, that index that it points to, we need to find the minimum length of an array up to that point. Now, that minimum length is going to be infinity if there was no subarray that's summed to the target. But if there was a subarray or range that summed to the target, it would store the best length, so we would get the best length up to that point. In this case, by doing this, we're preventing it from overlapping. I don't know why I breathed like that. I don't know, so I kind of messed up on doing this one in the video. I could re-edit it and redo it, but I'm probably not going to do that. I think this is a problem where, like, I had to look at a solution to kind of figure it out. But it makes sense now. Yeah, it's just like taking the difference between two previous arrays. Like, I can relate it to a different type of problem. Okay, what else? I think that's it. So yeah, so thank you for watching.